Good morning to all. Today myself Mukan Singh Broad with student ID number S1508591 is here to present assignment number 1 for BIT243 for which the subject is network security, and these are few tasks which we will be performing here, which I'll be explaining, which I performed in my presentation. So let's get right into it. So, as I told, my name is Mukan Singh Brock, student ID S1508591, and okay, let's start with task number 1 using firewall, right? Okay, so firewall is a network security system that filters and controls the traffic on a predetermined set of rules. This is an intermediary system between the device and the internet. IP tables is the default tool provided in Linux. To establish a firewall, IP tables is used to set up, maintain, and inspect the tables of the IPv4 and IPv6 packet filter rules in the uh, Linux kernel. So IP tables consist of a front-end program called UFW, which is uncompiled firewall. It uses a command line interface consisting of a small number of simple commands and uses IP tables for configuration. We're on slide number 2. Here is our task. So first what we'll do is first check the tailnet connection by using command tailnet IP of machine B, as you can see in the slide here. If it gets successfully connected with machine B, then tailnet connection is established. Now, to prevent machine A from doing tailnet to machine B, a firewall rule is to be created. So the tailnet work on port 23. So by using the command sudo ufw deny out 23, as you can see here, will deny all outgoing packets from machine A. When rules get updated in IP tables, it will block the outgoing packets on port 23 and prevent tailnet from machine A to B. So now to next slide. Yes. So now to prevent machine B from tailnet to machine A firewall rule is created on machine A by using command sudo ufw deny from IP of machine B to any port 23. So this command will block all the outgoing traffic on port 23 from machine B. After creating the rule, go to machine B and uh, try to telnet machine BA by using command telnet IP of machine A, and it can be seen that it will not connect with machine A, and a message will appear after some time, which is connection timeout, like connection timed out, right? So in this further task, in this task, we will prevent machine A from visiting an external website first. So first what we have to do is we have to get the IP address of that website by using the command ping ping website name. After that, reject all the outgoing packets to that IP address, to that particular IP address which we have found of the website by using the command sudo ufw reject out to IP address of website. So we will write this command in there. So after adding this firewall rule, we can check that by ping command that the host is unreachable now. In the image, you can see that I try to block the access of YouTube website. First, I use the ping command to get the IP address of YouTube website, then rejects all outgoing packets to this address. So our task 2, which is implementing a simple firewall. So how we can do that is NetFilter offers us various functions and operations for packet filtering, network addresses, translation, and port translation, which provide the functionality required for directing packets uh, through a network and prohibiting packets from reaching all the locations like within a network. So NetFilter offers something called NetFilter hooks, which is a way to use callbacks in order to filter packets inside the kernel, right? So here are the 5 kinds of NetFilter hooks you can see on the screen. Moving forward, we have uh, in this task, so we have to set up Linux environment, right? So in this task, packet filtering module is needed to be implemented by using LKM and netfilter. For doing this, first we need to set up Linux environment by using the following commands. First, switch to root user by using command sudo su after install the module, and by using command up get install module assistant. Just the normal commands. After installation is successful, prepare the module, and the command which we use for this m-a prepare. So according to the requirements, at least 5 different rules must be supported as per the assignment. So these are the hooks I have used, and by using these hooks I can create some rules. So let's see what we have done. In rule number 1, I am preventing machine A from telnetting to machine B. So as we can see, when we telnet machine B, we get a message connection timed out. So when we see the log message using the command dm message, the following command, the output is received and dropped. TCP packet going out to the IP address 192.168.4335 with port number 23, which satisfies a requirement for this rule. Moving on to rule number 2. In this rule, I am preventing machine B from pinging machine A. As I ping the IP of machine A from machine B by using command ping IP of machine A, we are still on the same state of machine A as the previous rule, and we cannot ping from B to A. We cannot get any reply back. We're not getting a reply back. It will always be waiting. If we like stop the ping, we get the message 100% packet loss. Moving on to rule number 3. In rule number 3, I am preventing machine B from tailnetting machine A. As we can see here in the slide, that when we tailnet machine A, we get a message connection refused, and when we see the log message using the command dmest, same one, the output is received and dropped TCP packet going out of 192.168 again with port 23, which satisfies our requirement for this rule. Now, uh, aggress filtering. This is our task number 3. Aggress filtering is the practice of monitoring and potentially restricting the flow of information outbound from one network to the other. Typically, it is it is the information from a private TCP, or you can say IP address computer network, to the internet uh, that is controlled by that. So, for performing this task, for blocking all outgoing traffic to external tablet server, a firewall rule is to be set. So, as we know, the tailnet uses port 23. We've used in previous tasks as well of its services. So, for blocking the outgoing traffic, we will deny all the outgoing packet on port 23 by using the command sudo ufw deny out 23. Before running the command, make sure that the UFW service is up and running. If the service is inactive, then obviously the firewall rule does not work, and will uh, also enable the UFW service so that it keeps on running even after the system gets reboot. So here, for blocking the outgoing traffic to facebook.com, as you can see, an outbound rule is to be set up. In the image, you can see that the first is I try to access the facebook.com through the browser, and then it can be seen that Facebook page is accessible. Now, to block access of the facebook.com on a machine, first get a facebook.com IP address by using ping command, as we did in the previous task. After getting the IP address, set the outbound rule for blocking the packets of using the command sudo ufw reject out to IP of Facebook, and hit enter. And after that, the rule just gets updated in the IP table. Now let's try to ping again with facebook.com, and it can be seen that packets are getting rejected, right? So now from browser, it can be checked if system still able to access the facebook.com or not. And after entering the facebook.com in browser, the message will appear the message will appear showing unable to connect. It means that outbound rule is successfully established and outgoing traffic is completely blocked. So, to summarize this assignment, after doing the practical, we have come to know that it is very important to set firewall rules as anyone can get access to the system by telnetting. UFW is the best command line program for setup for for setting up the firewall rules by using net filter, and we can filter the packet. We can filter the packet inside the kernel during the runtime without rebooting the system. While using LKM and net, a proper attention will be given during programming. Any mistake can cause kernel crash, and evading egress filtering very um, is very well filtering system, as it like ensures that unauthorized or malicious traffic never leaves the internal network. So that was all